Many of you should feel very comfortable with this. These are called irrational numbers. Basically, ladies and gentlemen, irrational numbers, there's only a couple things that fit into irrational numbers, and they are pi, a little symbol pi, it's one example, and square roots that don't work out. Okay. And the reason for that, the technical definition of an irrational number, okay, are all numbers, okay, numbers that are non-repeating, you'll like this, non-terminating decimals. In other words, for a number to be irrational, when you actually figure out what it is, you get a decimal number that does not repeat, nor does it ever end. And that's what makes it irrational, because our minds really can't grasp things that don't end. For example, pi is one of them, because if you do pi out as a decimal, and I'm not 100% sure how to figure out what pi is as a decimal, you see there's a small piece of it. But people have done pi out to hundreds and thousands of decimal places, and it will never ever end. Okay? Same thing with the square root of 2. If you tried to figure out what number times what number would give you 2, and I can kind of do that. I think I've done that for you before. If I go here to more tools and I hit calculator, and I hit the square root of 2, I get 1.414213562373095, and the only reason it ends there is because this calculator, that's all the digits it'll allow. Okay, the square root of 2 will never ever work out. Okay, same thing with the square root of 3. Now you have to be careful, because if I asked you if the square root of 4 is irrational, it is not irrational. It's actually a rational number because there is a square root of 4. What times what gives you 4? 2. So this is a rational number. It is not irrational. Okay. Same thing with this. And you probably 0.3 repeater. Rational or irrational? Rational or irrational? Alex? It is rational. Okay. Because in order for it to be irrational, it has to be a non-repeating decimal. For the simple reason, all repeating decimals, children, can be turned into a fraction. For example, 0.3 repeater is the fraction 1/3. And that's rational because you can understand 1/3, a third of an apple. Okay? Unfortunately, 1/3 doesn't translate into a decimal very well. It just keeps right on going. So you have to be careful with that. It has to be non-repeating. If you see a repeater line over something like this, if you see 3.168, and there's a line over that 6/8, that number is a rational number. It's not irrational, because a irrational number has to be non-repeating. And a line above it means it is repeating. Okay, so again, the only things you are going to find, okay, that are irrational are going to be pi and square roots of things that don't work out. How about the square root of 15? Rational or irrational? Is there a square root of 15? No. I mean, not an easy one. Okay. Square root of 64 is rational because the actual answer to that is 8. Now, just because they're irrational, that doesn't mean, Sam, that doesn't mean that we shouldn't have some idea what the number is. Okay? For example, if I give you a number line, let's say we go 0, 1, 2, 3, 4, 5, and I say, put for me as close as you can where the square root of 5 is. If I was giving you the square root of $5, where on the number line would the square root of 5 go? Or what numbers are close to what the square root of 5 would be? What is an approximation? Use this little squiggly little sign there. What's an approximation for the square root of 5? Okay, and to give you an idea, think about square roots that you do know. Well, we know what the square root of 1 is, right? Square root of 1 is 1, correct? We know the square root of 9 is 3. Are there any square roots in between that? We know what the square root of 2 is. The square root of 4 is 2. The square root of 5 falls somewhere between the square root of 4 and the square root of 9. So a good guess for what the square root of 5 is going to be, Taylor?
2.5.
Well, 2.5 is probably closer to 2 than it is 3, just because the square root of 5 is closer to the square root of 4 than it is the square root of 9. But the square root of 5 is going to fall somewhere in this general area. Okay? We can't pin it down exactly, but we can get awful close. Okay? And here's a good thing to remember. What? If I know that the square root of 1 is, if I know that the square root of 2, remember I showed you it was on the calculator there? 1.414. Okay, if I know the square root of 2 is 1.14, the square root of 6 would be close to what? How much bigger is this than that? 3 times bigger. So 3 times, no, that would be right. This would be 3. What would the square root of 6 be close to? I don't think you can't think about it like that because you have to multiply by the square root. Sorry. Let's just skip that. Forget I even mentioned that. Let's move on to something new and more exciting. How about the square root of 10? Where would the square root of 10 fall on a number line? Think about the square roots that you do know, and where would the square root of 10 fall with those? Ashley?
Around a little above 4.
Well, a little above 4. So we know that 4 is the square root of 16, right?
Oh.
What's the next? That's 4.
A little above 3.
We know that the square root of 9 is 3. So the square root of 10 has to be a little bit bigger than the square root of 9. So yeah, it's going to be somewhere around here. The square root of 10 would have to fall somewhere. How about one more? What about the square root of 70? If I asked you to point to me, and it's not going to be on this number line, but what square root of 70, to give me a good guess what the square root of 70 would be? Think about what some square roots you do know that are close to this. What's the next perfect square less than square root of 70? One that works out. The next one less, Emma, could you check? Square root of 64 is 8. What's the next square root bigger than 70 that works out? Holly? Square root of 81, which is 9. So you know the square root of 70 has to fall between there. Which one is it closer to? 6 away from that, 11 away from that. It's a little closer to the square root of 64. So it's probably going to be closer to like 8.3 maybe. And you can figure that out. Should we try? What is 8.3 times 8.3? It gets a little cumbersome. Check this out, 9886, 68.89. Should we try 8.4? Yes, let's do. You know what 8.4 times 8.4 is? Oh, look at this. 70.56.
8.35.
So Sam's got it. I would actually go probably a little more like 8.38.
Yes.
Let's try that with a calculator. 8.38 times, what's my time sign? Times 8.38. Ooh, 70.2. It's a little less. That's 8.37 times 8.37. Ooh! Now, if you had a calculator, you could keep going smaller because we're pretty sure it's not at 8.37 is too big. So we have to go 8.369. 8.36. Oh, sorry, I messed up.
That's even higher.
8.369 times 8.369 equals.
Oh!
Too big.
Do
8.367 times 8.367. Oh! Still too big. 8.366 times 8.366.
Oh!
It was too low. So 8.36665. 8.3665 times 8.3665. Oh! 8.3666 times 8.3666. What do I have to do? 8.3667 times 8.3667. See, and the point of that is, I could keep really doing that forever because I know it's irrational. I will never ever get, if I had the world's biggest, longest calculator, I will never ever get 70. I'll keep having to do it. We just had to do that. We keep getting either a little too low or a little too high, and we keep adding digits onto it. That's what people have done with pi, and it will never work out. Now again, it would work out on here when I got to this point over here, and the calculator wouldn't do any more calculating because it's too big or small of a number, too many digits. But in the real world, that problem would never. Now we worked it out to what? What was it? 8.3667?
Yeah. 5.
Was it 8? Was it 5? It might have been 8.3665. Which, for most intents and purposes, is going to be close enough for what you're working with. Where do we use square roots a lot?
On our math papers.
Right triangles. And if your parents do anything in the world of construction, I guarantee you they use stuff like that all the time. So, with that being said, let me give you one example problem, because here's what they're going to do. They're going to throw at you stuff like this. 0, 1, square root of 2, 3/4, 0.5, and negative 0.6. And they're going to ask you to give that in order from least to greatest, which means you got to get them all in at least close to some sort of form. 3/4 is pretty easy to change to a decimal. That's 75 cents, which is 0.75. But the square root of 2, which wouldn't be a bad thing for you to kind of commit to memory, I can put it up there. The square root of 2 is close to what? 1.414. And now if you're ordering it from least to greatest, obviously you go with negative 0.6 because it's the only negative number up there. What would come next? Anybody? 0. So then what would come next? 0.5. And then 3/4. And then 1. And then the biggest thing there is the square root of 2, which is 1.414. So you just need to, the square root of 2 doesn't mean a whole lot to us like the square root of 2. Okay, But if I said you missed the square root of 2 problems on your paper, most of you would look like, I don't know what that means. Okay, but you need to be able to get the approximation or what it's close to right there. Wasn't that exciting?